Hi, this is Coffee Compiler Club. Anything to do with compilers and language runtimes and exceptions, which sounds like some of the people who showed up late. We'll probably go exceptions here today. They're all fair game. You're being recorded live. You'll show up on YouTube in a couple hours. You don't like that, bail out now. Open mic, ask what you want. I reserve the right to moderate. Never had to do it, and that's it. And we just started with Alan saying something about everything is an exception or anything can be declared an exception. And we were talking about exceptions and we decided to postpone it till we had a quorum. So Alan, you want to start us off again?
Okay, yes. So what I was saying was that I was researching exceptions for the past few weeks, okay? Because I want a good exception handling system. And, you know, everyone has complaints about exceptions in their language. So anyway, so what I've ended up with is because nobody can agree on what an exception is. Everything is an exception, at least. All you have to do is declare that it's an exception and it'll suddenly be an exception.
What does being an exception mean?
Well, it means it unwinds when you use it in an unexpected way. So like, unless you know you're dealing with an exception, when you try to deal with it, it throws and it unwinds the stack.
But the main point is when it throws, right? We have to first discuss the totality of the functions.
Yeah, so like, I mean, there's this thing where you write, you write throw exception A, and then you add it to throw exception B. And the question is, which exception do you get?
Well, the answer is that you shouldn't.
Yeah,
never mind.
Like the answer I mean, is nobody seems to have thought about this in very great detail.
Oh no, many people have thought about this, and there's no reasonable answer. Yes. There are various bad answers that folks have tried. A answer that you get out of Java is that if you're in an exception handler and you throw, you don't complete the handler you're in, you take that exception and go to the next outermost layer handler. And it's logically consistent, but it leads to some surprising behaviors when you start throwing inside handlers. So I don't claim that's a good answer or a bad answer. I'm just saying, been there, implemented it, done that. It's consistent, you know precisely the semantics. The behavior is frequently not what you want.
Anyway, so that was kind of old news. I mean, the news this week was that I was discussing exception handling with some kernel developers. Ooh. And the way exception handling works in the Linux kernel is that they return an error code from a system call.
Yeah.
And so I was like, well, you know, is there like a list of exception or error codes that can be returned? And they're like, no, we're kernel developers. We can return whatever error code we want from whatever system call we want, and you have to deal with it because you're user space.
Right, but they are enumerated.
Right, so there's only like 133 codes.
Yeah, but they aren't specific enough. There are some errors that are ambiguous. They doesn't indicate.
Right, and then they overlap. So like you have to do after the fact work to figure out where the error in the kernel, the error code came from.
So
don't call things that are going to error then. Like, isn't that on you? Come on, Alan.
I'm sort of the opinion here that there's a large step forward to claim we don't have exceptions, we only return an error code, and then there's a small step forward to say, and the error codes are consistent, unique, and contain the right set of information or whatever. But the first major piece is your stack doesn't unwind when you make a kernel call. I see. Would you like to see out my backyard, the hummingbirds floating around the trees with the, in bloom, the tree full of pink flowers, and Sunnyvale versus, I don't know, Vermont, Montana.
During the winter, what we do with the hummingbirds is we put them in little ice cube trays.
Yeah.
We make hummingbird ice cubes. Everyone loves them.
Thanks. It's just same thing we do with the unicorns.
No, they're too big.
We make all of our kernels using unicorn tears we got from waterboarding all the unicorns.
Mhm.
I see.
Yeah, fine. All right.
But yeah, so the kernel doesn't give it to you, but sometimes you totally want a stack trace or a memory dump or a.
Okay, well, let's slow down here for a second, because there's several different things you just said. One was, I want a stack trace, as opposed to what? An error return or a crash? I'll totally take a stack trace over, oh, you dumped out to the kernel, IBM 360 got an abnormal end, and core dump, okay, fuck. Stack trace is hell nicer. But you could argue that I ever gave you error codes and you had to deal. And then if you have to deal with error codes at every step of the way, you're annoyed. So then you get a throw. But if you have a throw and you declare it, you're annoyed because you have to write throws fucking everywhere. And so you quit and you come up with a version of throws that is by default, and you don't have to say it everywhere. Then no one knows what's getting thrown. And then you have the problem of when you throw and you want somebody to catch, why do you care to catch? Well, if I'm in the debugger is my catch handler, and it's going to let me investigate and repair a situation, fix my bug, maybe, whatever. But maybe if I'm running a web server and some stupid ass piece of code I ran just barfed from this web page, all I want to do is throw the page away, recover my state, and go serve the next web request. And how do I write? What's the semantics for the handler? What's the semantics for when I throw, when I catch? What's the rules on when it's too much grief to say I have to unwind every fucking return from everywhere because it has a code and an answer, and I have to look at the code to decide that I got an error or not, or what? I think that's sort of the space of interesting questions that I don't think the community as a whole has got a resolution on.
So my sort of canonical use case, which I admit is not everybody's, is the web request one. Somebody makes a query of death. The whole thing explodes. I don't want the entire JVM to end and take out all of the stuff that's cached in memory with it, because I don't want to rewarm those caches. So I want it to propagate up to the top of the request, log out something that my developer can use to say, this is a query of death. Don't process it in the future, preferably without spending an enormous amount of time and energy and compute power rebooting the JVM over and over and over again each time this query happens.
Yeah, it
Right.
takes careful planning though to accomplish something like that, because you have errors that are repetitive, you have errors that are parameterized, and you have errors that are, I think.
Okay, hang on. I have a editorial issue. Cameron, your volume is very low. Aaron, your volume is very high. I can either get blown out by Aaron or can't hear Cameron. So both of you tweak your volume settings a little bit, will probably be better overall.
Is that better?
That's better, Aaron. Thank you. And Cameron, you have to say something, not just sit there.
How's this? A little better?
No, but Aaron lowered his, so now I can turn my master volume up.
All right. No, what I was saying is you have to really carefully prepare for things like that, because it doesn't just happen accidentally. You have to actually have an entire kind of front door to the system that's analyzing the requests and what the results are and looking for patterns. Because what you want to be able to do is, differentiate between a complete outage and, maybe there's an outage of some subsystem that certain things depend on. And so, it's like, how do you differentiate all those? And it's very hard to tell at the front door what to do, unless you plan for it.
There's another issue, and that's just simply safe recovery of all the state that was in flight at the time the crash happened. The JVM gives you shit like the locks get unwound and garbage collection picks up dead objects. But if you have locked something, you locked a meta OS thing, like a database connection, and you don't unlock it, then you lost that connection. Right. So there can be other internal state things amid changing the state of X when the crash happens. I don't complete the job. Now I have something in an inconsistent state. And how do you define consistency and how do you get back to being consistent? The database properties, ACID, one of them is being in a consistent state. So, the transactions that you get out of a database said, all or nothing, and the goal there being that the all left you consistent, same as the nothing. You started consistent, you did all the transaction or none of it, and there you're consistent again, even if something in the middle wants to crash on you, in which case you rolled it back and you didn't do any of it, so you're still consistent. And that's the problem that in general we don't have a good answer for. The DAVM only gives you a partial answer. I know Cameron's, one of his goals is to make it easier to get back to a consistent state, because any individual service crashing won't impact another service in any way, except by the response of the error messages come back. So each service is responsible for maintaining internal consistency and is only given a very narrow view of the outside world so that it can easily filter for consistency internally.
And I'm actually just in the middle of prototyping a web application right now.
There you go.
Finally getting to do something fun. Well,
Excellent.
Writing a database is fun.
So one of the things that we had to do in H2O was when somebody became inconsistent through an exception, unwound, all of the in-flight process that were in the work subtree underneath that particular crashing thing had to all clean out completely so that we could launch another job against the same data on the same resources without ever burning up something that you would then eventually run out on. So there was actually a lot of engineering that went into cleaning up random exceptions that came from user land in the middle of nowhere.
Yeah, I think there's I'll botch the saying, but there is some saying out there about the hardest thing to write in the operating system is kill.
Oh yeah.
And
Absolutely.
You know what I'm talking about.
Yeah.
It's one of the reasons why Java never got it to work. The thread kill.
Thread.def, sir. I totally met the Java semantics for thread.def. You can argue that they're stupid semantics, but I follow them 100%. And they were a bitch, yeah. The most difficult thing, honestly, was getting Stack Overflow to be 100% on the semantics. That one was the most major bitch. Kill was a much smaller issue.
So I can have a system like Erlang, where the advantage is I get to define my supervisor trees, so I can have some idea of where things die and where the borders are. The disadvantage of Erlang is I have to define my supervisor trees. Like, do people have opinions on define your supervisor trees versus try catch versus how else do you define the boundaries of where the exceptions go?
What is this guy doing? Huh.
I mean, clearly Cameron wants to define his boundaries.
I have to go read Shipleff's tweet here. That looks very interesting. And stack banging. Oh yeah, I totally remember stack banging. That was things. So super.
So how do you do it? How do you do it today, Aaron? What's the?
Yeah.
I assume there's a certain language in use.
Java, try catch.
Yeah, I did it in H2O, but manually with great effort. There were a lot of corner cases that took a while. Part of the rescue was garbage collection. We'll clean up dead things, so you can just ignore that. But the other aspects were making sure that I was back to a consistent internal state, which involved a lot of errors and trial and error and crashing going on until that got, well, we assume correct. It wasn't formally proven or anything. 2 more people showed up here. There he is. Sorry. Yeah, trying to do 2 things at once badly. I cannot walk and chew gum at the same time. Sorry, or edit a spreadsheet and chew gum at the same time. I don't have an answer that lives within try catch. I think what Cameron says is interesting. The other thing I did a lot of state machine programming, both H2O and non-blocking hash map, for which consistency was defined by the state machine, and which typical answer was every state was valid and consistent, so it didn't fucking matter. And then your semantics drove out of that. Like, this is the behavior I got, but it's all consistent. And then as soon as you figured it out, yeah, it hung together well. And so you couldn't get inconsistent because every transaction was a single CAS. and that brought you to a new, different, consistent state. That kind of
Mhm.
programming is a bitch.
I know we've talked about it before, jokingly at least, but with respect to Aaron's question, the try catch in Java, if anyone has ever spent time looking through production logs, so for
Yes.
example, without naming any particular telcos, there are apps that people use that generate, kid you not, gigabytes of exception dumps per minute.
Oh,
And
My
that's
problem with exceptions in try catch, and you don't know generally where they can happen. They're just handled inside the code, and three
Well,
functions
worse.
down the way, you don't know what can
It's-
happen.
I think it's far worse than that, though. In most applications, they don't ever look at the exceptions. And I'm not joking.
Yeah, yeah.
Okay, so I'll
Agree.
claim that most people can't handle an exception anyhow. They shouldn't try to catch.
Correct.
The catch should happen somewhere else. People who catch and log and then throw again should be shot. You shouldn't bother to catch if all you're going to do is log and throw again,
Correct.
because you're fucking going to get a log anyhow, and you can't do anything about it. You're not recovering anything, so don't fucking catch.
Yeah. And the exceptions also tend towards 0, 1, or infinity.
Yes.
And that's the other thing to keep in mind. The only ones you're actually interested in generally are the on the order of 1 exceptions. 'Cause
Well,
in
you want to
some
take
order-
the infinities to 0 at some point.
Right, but it's usually the same exception over
Oh,
and
okay,
over
fine.
and over again.
Yeah. So it's just, you're right. It's just the 1. Yeah, that's fair.
Right. So Aaron, what you generally need is some way to categorize the unhandled exceptions, and spank people for handling exceptions. But you generally want to categorize the unhandled exceptions into that 0, 1, n bucket, right?
Yeah.
So basically, they're exceptions that shouldn't be happening, and it's an application bug, and they need to get rid of it. And then there are exceptions that actually indicate, this is one I haven't seen before. I should probably pay attention to it, right? Because what you're really trying to do, at least on the production side, is figure out if someone should wake up, get out of bed, and look at it, right? That's what it usually boils down to, right? Because you've got, I'm not kidding, like gigabytes of data per minute in a log file, mostly exceptions.
Well, yeah, right. There's your problem.
And you can't be looking at it. It'll kill you.
Yeah, right.
We have said it before. Exception should be exceptional. Yeah.
So there's I don't know what to do here kind of exceptions for which I claim the answer is you shouldn't do anything. You should let the exception just carry you out and blow you out, and somebody else has to handle it at a higher level. There's the bad API I'm given throws an exception when it ought to give me an error code. I get an IO error instead of a file not found code. File not found happens all the fucking time. So does disk full. So does 1,000 other ones that are commonly thrown that should just be an error code. And there I claim, bad API, fix your API. If you're stuck in the land of Java, you just catch it locally and turn it into an error code effectively. Carry on.
Yeah, end of file. You'd be amazed the number of files that have an end.
Oh, in.
The other problem is exception is wrapped and wrapped and wrapped and wrapped and wrapped and wrapped.
That
and
goes
wrapped.
to the handler, and I'm of the opinion that you should be punished for handling an exception. That the answer for handling it is you can't throw, you must handle. If you wanted to do some minor cleanup on the way out, then you're not catching, you're doing a finally clause cleanup.
Right. Which rethrows the same exception.
Exactly the same
Automatically.
exception with the stack trace. And if your finally code can throw an exception, then there's some other rule that says something like, I don't let you code, that's incorrect code. Or I'll ignore your new exception. And the Java model is I lose the old exception and give you the new one.
So the other mistake in Java is that the finally doesn't get past the exception, which is always annoying.
That's a good point. You have to have a catch in a finally. And you have to do
Yes,
some of
that's
the
correct.
shit in the catch and some of the
Yep.
shit in the finally. And you're right, I've totally passed flags back and forth from the catch and the finally.
So but the thing is, finally should be able to throw an exception, but it should only be able to throw an exception in an exceptional case, right, Tidor?
Yeah. So we move.
generally finally should not throw an exception. It should be mostly immune to failure. But if something terrible happens that you should know about because it blew up in the finally, then yes, it should throw an exception.
So we move for sections of code you cannot throw exceptions. So we move for specific places you can throw.
Yeah. Okay, let me just confuse the muddle waters one more time. Then there's a class of exceptions for which I claim the only reasonable correct answer is a panic that you can catch in a debugger maybe, but you're not ever going to handle it reasonably. And that includes shit like out of memory. I don't know. I mean,
Yeah, and that's pretty tightly tied to the runtime model,
Yeah.
because if your debugger is built in the same language.
Well, I've been reading
So if I want to
several-
minimize catch and rethrow, does it make sense for my classes to have two destructors on them and say this is the happy path destructor tearing everything down, and this is the something's wrong, please clean up yourself?
I believe you should indicate some exceptions are recoverable and some exceptions indicate a very bad state of the program.
Yeah, there's definitely the runtime took an error and you're going to do nothing you can do about it per
And I
se.
think Aaron's question is different though. It's
Yeah.
almost like he's thinking in terms of RAII as you unwind. Do you want an alternative
Yeah.
structure
Yeah.
for an exceptional path?
I've written Go code that didn't need to do some kind of catch the exception, do some cleanup, and then rethrow the exception because I had to defer. And I just said, here's my defer statement to release all of the locks and assets and things. Run it at the end, whether an exception blew me up or whether I just returned.
I
That's
heard the
finally
problem.
clause.
I heard the problem in the start of your statement when you said, "I've written some Go code."
Yeah.
No, we could go. Yes, let's go exceptions. I mean, let's go past the go versus nothing.
You know the motto of Go, right? Because C just got too bloated.
Doesn't Go have generics now? I'll stop going behind. No, never mind.
Yes, they just added generics a couple weeks ago into. I think it's still a pre-release. Looks pretty good actually.
Excellent.
So Alan, you were saying something?
Oh yeah, so I mean, I was reading these .NET posts and they were like, oh yeah, out of memory, of course we should recover from that. So like, I mean, so there's this thing called the constrained execution regions, I think is what they're called.
Excellent.
So like there's special regions where they aren't allowed to allocate, and like they JIT them in advance so that you don't have to worry about the JIT allocating memory, and they do all these things, and so and at the end of the day you can run code that recovers from out of memory errors. But like if I remember right, what happened was that they were too complicated. And so like when Microsoft open sourced the .NET stuff, they actually deprecated them. So it's like, yeah, right. It's only supported in .NET Framework. They're not supported in .NET Core or .NET 5 and above. So
Excellent. So in the land of H2O, I technically recovered from out of memories in a limited case that was the common case, which was you inhaled a giant new data set and I made a mini megabyte allocation for the pieces of the data. And that giant allocation blew out. And in that case, I did recover. I technically caught the out of memory. I didn't get the allocation I wanted. I triggered that this entire data set needs to get rejected and all memory already allocated for it should get freed and the GC cycle should run and the user should get told that he's out of memory. And that recovery actually worked fairly well if that's where you took it. But if you took an out of memory in the middle of allocating some tiny fork join thread thing, you were toast. And as for Aaron's question, I don't know what's reasonable. Like the Cameron model, as I understand it, sounds very good for error recovery. That service over there is a modest size thing, which through an internal exception goes down in flames and we burn it to the ground and make a new one. Like you just did an OS did a kill and spawned again. And everyone who talks to them through a narrow channel, not shared memory. And so we all can look at our narrow channels and discover that this service got burned to the ground. And we all, they're talking to this guy, figure out our recovery paths separately. That's very similar to like the Erlang model where just crash it down, throw it away, make it anew. That seems reasonable. You want to do shared memory recovery, you have more issues. And the concept that I've toyed with is like your defer, there's some version of a cleanup that will execute on an exception unwind, but that cleanup has itself, I want to say can't throw an exception, but I don't know if that's technically possible. I guess it technically is possible. I claim shit like file close will never throw an exception. It'll give you an error code back if your file wasn't open, for instance. But if you file close, it'll just never throw, it'll close. You want to free some shared memory thing and it wasn't allocated in the first place. Okay, fine. There's no exception there. There's a bunch of these cases where I can imagine an unwind could be type safely made exception free. And if he has other error codes to report, they can be piled on to the exception throw statement, maybe, or maybe not. Like no one really cares. Typically it's best effort, I'm getting out of here. The Java model, which I saw replicated in C++ as the hotspot error recovery code, but I saw this happen repeatedly in Java as well, would be my finally clause did something complicated, it threw an exception as well. That superseded the original exception. So when I finally got a stack trace back, I lost why I got here, and I had to go diagnose the breakage in the nested finally clauses, one layer at a time, each time re-getting some exception that was the root cause of every issue and discovering that some handler was broken, was throwing again. Once the handlers got unwoundedly corrected, I could get to where the root exception would throw, go through all the handlers, I would get the fucking exception and be able to do something about it. And you know, that was not a pleasant debugging experience. I've done, like I said, I've done it both in C and in Java, or C++ and Java, and I don't think that's the right way to go. Essentially, oh, this plays into the hard. I did this hardware co-design of Azul, right? And one of the things the hardware guys come around to is, you know, what you gonna fucking do when the hardware makes a mistake? Well, the answer is, you know, I gotta go turn it back around at the fab. It takes 6 months and 100 grand. No, everything is valid as a state. There are no errors or no exceptions. There are just some funny states that you don't like, but you have to make sure every fucking state has something it does and does something sensible.
Yeah, but silently will corrupt. That's the problem.
Yeah, so the hardware guys try very hard to make sure that there is no holes in their state machines and there's no silent corruption that way, right? That there's a different kind of planning going on. Like I said, I've done a bunch of state machine coding. It's obnoxiously difficult in the software land for lack of good tooling, but it does have the, you know, the advantage that all states are valid and error recovery is just another state.
I think CPUs these days have chicken bits, which allows the engineers to chicken out of certain features.
Oh,
so,
yeah, that's been around a while.
That really helps to like not have to re-roll the whole fabrication process.
The Azul first chips that came back had a limp along mode. One of them, they could have the fusible links they could cut with an ion beam. And so like the L2 caches had huge issues with yield, but they could find one way out of the 4-way associative cache that would not have issues. So they would burn the links and get you 1 out of 4 ways. So you'd have a single associativity 1/4 side L2, but you know, it mostly worked. So on a 24 core die, that first one that came back, we had like 18 usable cores, most of which had 1/4 sized L2s. But good enough for boot the OS and limp along. There are other fun problems they had. I could tell you about hardware bugs. This is different. That hardware guys do some fun shit while they're debugging their shit. But unrelated. Yes, chicken out bits. I don't know what you do. This is the software side. What do you do for exceptions here? I think there's some bite the bullet thing that has to happen that's not pretty for folks.
An approach that I found that, at least for me, worked reasonably well, basically, as some people already mentioned, is the distinction into 3 different types of exceptions. So for instance, like exception type A is the CPU is burning and because the house is on fire, so things that are not recoverable. Number 2 are programmer errors. So you like
Melody reference.
exactly, or try to access an array index that like wasn't there, etc. And the last type is like general problems like that.
File exception.
Yeah, that's the things that are not exceptional, and but
Something happened.
and what I'm quite happy is to say, okay, 2 kinds of exceptions can be thrown. It's the type A and type B, and type 3 doesn't exist, and you can't catch exceptions. So
we can't catch it all. The debugger catches them, right?
Yeah. So basically, the programmer errors and like houses on fire errors are panics that are not recoverable. And the third error state is basically not exceptional, and that's like use option or use result or use any other kind of type. And
let me throw you an as if case. I just heard somebody mention earlier on this call. I'm writing a web server. I call out to some code written by one of my junior developers to handle this web page. He did a range check exception because he screwed up his math by 1. I shut down my web server, or I catch the exception, throw away the attempt to go access this page, and carry on. And what I heard you say was, range check exception, cannot be caught, panic time, down you go. And I'm like, I kind of want to sort of recover from that at some level.
And there is more that is happening in the web server. You can drop the request, but because each request is a different user, there is some multiplexing there happening.
So if I've defined my web server such that every page is being loaded in a separate process, then I burn the process down, kabang, kabang, and I'm all happy. That's kind of sort of Cameron's model, which I've kind of sort of like. I don't know how much of it I want, but
futures,
I like some of that.
Scala futures or something like that. You can cancel the future is a container that can be canceled. That can be.
When you say container, you don't mean an OS container.
No, container of some kind of something, a type. Container.
Right. So as soon as you said
like
I have Scala,
like a result type, for example,
you have shared memory. And now what's the cleanup rules for shared memory?
Yeah, they suck.
Well, exactly. And
it's not just shared memory, because it's also handles from the operating system, and it's locks maintained by the VM. I mean, there's a lot of complexity. I'm not saying that it can't be handled, but it is complex.
What do you want to expose to end users? I think VM locks internally. I claim that's the VM the engineer has to deal.
Right, but there should be no synchronized keyword.
No, that's user mode locking. And then if I want user concurrency, I'm going to have user locking, but that means the user that the exception path unlocks, but doesn't necessarily leave you in a consistent state. So that's not necessarily the right answer either. And I don't claim I have the right answer there.
That was Aaron's point. Should the exceptions clean resources after themselves?
Okay. Yes.
And restore, right. So I guess the 2 themes here are the user is allowed to catch an exception, clean resources, achieve a consistent state locally, perhaps recursively up the stack, or perhaps at one time at a very high level, versus, I already have a lot of background noise, versus a game where there's more sandboxing going on. You threw an exception, the sandbox got cut off pretty harshly at some other higher level by some other mechanism. For Cameron, that would be services in their containers, or an actual container on a process job, microservices. And do we want to explore when you'd rather have one or the other? Yeah, like one of them Sorry, go ahead.
I was just going to say that the cheat that we use is the hierarchy, right? Because when you have a hierarchy, it's the same cheat that RAII does, right? Like when you have a hierarchy, it's easier to clean up, right?
Yeah.
And when you don't have different hierarchies muddling in the same pool, so for example, mutable data shared across multiple threads,
Yeah.
then it makes it much, much, much easier. In fact, one of the biggest arguments for the Java model, and I would argue it's one of the reasons why it's been so successful for so long, is that previous to Java, it was basically impossible to have multiple threads safely working on shared data. So a shared mutable data, I want to be clear, obviously, immutable is easy.
Yeah.
So, and part of that is because without GC, you can't do it. Now, I know that it's theoretically possible, but there are only 12 engineers in the world, and a couple of them are on this call that I would trust to do it, right? It's just that brutal. I've done it. I've messed it up, so I know it's complicated. I haven't always messed it up, but you only have to mess it up once, right? Like that's the problem with bugs. I told you about my red-black tree where my nil nodes ended up being accidentally mutable in Java, and they would leak data from one tree to another accidentally because the rotation of the tree, they would grab a piece of data from one tree and then on the next rotation, stick it into another tree. Like, holy frick, like things that you don't want to have happen. Yeah. So Java was super successful at it, but at the same time, I don't think it's a good programming model. Like just because it's so hard to get right, it's so hard to clean up after, it's so hard to localize failure in, so when you have shared mutable data and someone blows up, what state did they leave it in? Because there are other threads that are using that data.
Yeah.
So an approach I'd be really interested in trying is to have, let's call it supervisors or something, so that if like one of your process crashes, the supervisor sees it and can decide on, for instance,
That's Erlang.
sorry? Yeah,
That's
exactly.
Erlang.
Yeah. So I think that because the problem with all the cleanup and the resources, etc., the whole question of like, what are we supposed to do? It feels like we are trying to like ignore the root cause and try to patch up symptoms. So in a sense, it's like the question is, okay, this process has encountered an error. Why can't we just throw away everything and start fresh? And the answer is because resources are expensive, processes are expensive, threads are expensive, everything is expensive, which would help us pulling this idea off. And I'm really thinking, okay, so what would be necessary to, for instance, let's have like a web server or something. What would be necessary to get this, to start up this web server once, get it in a steady state, and just keep it somewhere on a page and clone this web server for each request or for each user or something. And when you need a new request service or handler or whatever you call it, you basically take this immutable image, this immutable runtime image, and swap it into a new mutable page and just get it going. And I think if the progress, sorry,
there'd definitely be some expense there.
Yeah, I think if progress could be made there, maybe the whole balance of what's doable and what's expensive would change a bit and would lead to different outcomes in the discussion.
I believe they made share it because they share the resources. Because forking it is expensive, like forking a process, and that's the point. You want to share the most resources they can, so they're little as possible in order to execute.
I mean I think that's the issue that's worth tackling, figuring out why is this thing expensive, and figuring out solutions to that, and like in let's say alternative solutions to saying, okay, we have this mutable shared memory, multiple threads work on, and if one thread blows up, who knows what's happening to the mutable shared memory. I think that there could be better models to that, and it would be interesting in exploring that.
So in the land of mutable shared memory, like there are some cases where, I mean, this is like a progression of refinements can be done here. There are some cases where I have a well-understood theoretical result for what it means to be mutable shared. This would be non-blocking hash map. I don't care where you were in the process when you boarded out, the hash table is in a consistent state because it's a state machine. It's always consistent. Then there's data which is in shared memory, but it's actually only going to be privately mutated. And this would be your web services. You're doing a web request to Kaiser Permanente, and you're asking for your health records, and you're paying your bill and shit like that. That does not need to be in shared memory. And that state should be atomically updated eventually, perhaps using a database, but using some sort of atomic update mechanism. And the web request is busy doing a copy of the atomic safe piece that they are privately mutating the fuck out of while they sort your bill and take your credit card and yada, 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 whatever. And then they come up with an answer, hey, and then they present it to the database who atomically updates. But that piece of memory doesn't have to be in shared memory. And I don't know, what's the right way to say, I want to spawn a thread. It has some shared stuff it talks to, which is immutable. It has some private shit it's dealing with that he took a clone, a defensive copy, he fucking mutated it, and now he wants to atomically update the defensive copy. It kind of gets down to like transactions all the time kind of mindset.
Yeah, I think it's a bit like kernels already support this copy on write for memory, and would be interesting if copy on write was supported for more types of resources, how far it could be pushed, so that one can have like
have you used Clojure?
Yeah, exactly.
Yeah.
I was just headed for exactly Clojure.
Yeah, so that you can have like not only like your basically immutable memory that you basically copy as soon as a new process touches it and then works on its own copy, but also all other kinds of resources outside memory.
The experience out of Clojure is having fine-grained immutable structures with copy and write semantics is actually fairly expensive.
Yeah, it's pretty good considering how expensive it is. I mean, they have all sorts of optimizations, but yeah,
they try hard.
They try real hard. Yeah.
Yeah. And the answer is it's still pretty expensive.
Oh, that's Clojure. It's not a kernel level. Sorry?
Yeah, but this is done where you're just looking at objects and saying, oh, I have to mutate, so I need to clone this object. But I have to have a copy of everything above it leading down to the clone, so I get the rest of the structure shared still of my large, complicated hash table, dictionary, whatever I have going on.
I think what's the alternative, because it's I think we're comparing it into the wrong direction, because when I say would be nice to have like this copy on write concept for supported in the kernel for more than memory, I'm basically saying, okay, my process has crashed, I need a new process to handle these web requests, and I'm comparing the copy on write concept, which basically says, okay, you get like now a fresh mutable copy of the service, we just keep over there in an immutable frozen state. The alternative to that is basically
reboot it. Yeah.
Sorry?
Yeah, reboot it. Yeah, re-execute up to that state.
Running. Running a new server process, like reading the file, reading 50 config files.
Certainly heard about people attempting this, where they take a running clone and then they snapshot it. You have to patch up all your open file handles. You have to patch up your access to the file system. You have to delta offset this and that. There's a bunch of shit that goes on. It's not a free operation either.
No, I'm not saying it's free, but I think it would be interesting if support was good enough to actually make it work. And then if it worked, I think the performance would be better than the alternative of starting everything.
We have a slightly different take on it than what you're describing, but our plan is that because there's a lot of work that gets done when an application starts up. So the plan is to snapshot the application after it starts up, but before you put load on it. So kind of a clean start. And then of course, when we page it out, literally take the application out of memory, we'll do basically what you're describing, but we'll later restore it at that same point. But if there were a crash or whatever, we could restore the kind of initialized state.
Yeah. I claim that you're treading on dangerous grounds. You're welcome to try. Because you'll snapshot.
It's not applicable to every application.
Okay.
But for web applications, it's actually a fairly good model.
It's easy to snapshot a broken thing, and then you only ever restore a broken snapshot.
That is correct.
Okay, that's the obvious danger. You introduce state into the model. I have a fresh, clean start. No. I have state. And the state is secretly behaving, it's pretending to be a fresh, clean start, but it actually has state for some prior situation that hasn't happened in a long time. It isn't there now. But at some point, this config file was missing and the state booted up with the config file missing and took all these stupid defaults that are no longer correct. But if I go ask for it again, I got the broken startup.
That's why we don't have config files.
Okay, good. Just one of many, for instances, of where you can pick up state.
Oh yeah, no, so like all IO has to come in by injection. So all configuration comes by injection, for example. So, so any injection that changes would invalidate the entire system. You'd have to start it from scratch at that point, right? So, but it also means
you have a line that you put around, which is totally reasonable, and saying, I'll snapshot this as long as I can verify what crossed that line is the same. So I have to repeat the IO to verify it didn't change.
No, because this is a controlled platform. So, the configuration, for example, is done by an administration tool. So if anything there changes, it would automatically invalidate.
Okay, so the administration is part of my, I want to say, shared trusted computing platform environment.
Right.
I see. Because the obvious hack is I went in and I edited a bit in the config file from 0 to 1. And I saved it back out, and then I retouched the timestamp backwards because I didn't want to deal with whatever other things going on. But your snapshot didn't pick up my bit change.
So you're describing Kubernetes hell, and that's what we're avoiding. Yeah.
Excellent.
Are your snapshots portable in any way, or are you guaranteed to always be restoring on the same machine?
Well, they're perfectly portable at this point because we haven't implemented them yet.
Excellent.
Yes. So
it's the same machine.
Yes,
I opened the box, I took half the memory out and I put it back together, and you needed the other half of the memory, but it's the same machine. Now what the fuck do you do?
They're designed to be portable, but at the same time, there are specific things that we know will destroy the portability, including because the containers are hierarchical, any portion of a type system that's shared from a higher container into a lower container, whatever optimizations are done to that higher container will invalidate the lower container. So if we're not planning to do the real-time hotspot model, we're planning to do almost like a batched hotspot approach where we would be able to offline, nearline optimize, re-optimize the code. But once you do that, it invalidates any of because all your structures change, all your pointers, So think about it this way. It's kind of like loading an SO or a DLL, right? You have a certain patch table you have to go through and everything's fine, right? But if you rewrite the DLL, like you have to rewrite the patch table too. So we would just start over and initialize it from scratch at that point. Dan, I don't know. I think that answers your question, but let me know.
Yeah, I think so. It caught my attention because we've been looking at CRIU and playing with that in the context of Java. And trying to make those checkpoints portable has been an incredible challenge because it's not just the JVM you're dealing with, it's everything else in the environment, right down to glibc deciding that, oh, you have AVX instructions, so the copy we're going to give you is a different version, so you have to go and hack around that, and it was all these things we didn't expect to run into, and then did. One of my coworkers, Ashutosh, just posted to the OpenJDK crack list a document outlining some of the issues he's been running into trying to do this and the workarounds and horror he's had to go through to make it work.
You got a link? I see
Yeah,
Matt threw one onto chat for checkpoint restart.
And Intel just made it much more complex with this latest generation of chips as well. So the yeah, so it's about to get uglier, not better. Because this is the first generation where they actually took away instructions. So if you run on the old chip, you may not run on the new chip. We talked about that the other week. That's the big little bit. They've got the efficiency cores that don't have support for AVX. So they pretend to disable AVX on the performance cores. Charlie, you're nodding. Have you hit this yet?
I'm grabbing people's links and putting them into the doc here.
I've seen people complaining about it already, Cameron. They're like, what the heck are we going to do for some of the stuff that they're like, this is ridiculous.
Yeah.
But
yeah,
it is what it is.
Then there's people hacking the firmware to turn the AVX back on in the performance cores. So they basically have a chip where if the operating system accidentally puts a thread on the efficiency core, it'll blow up. So they basically, anyway, interesting. I think there's actually a pretty good answer there, which is you mark your threads whether or not they can run on the performance cores. You mark them if they can run on the efficiency cores, right? It has to
now you're right. There's another bug here though, and that's you're running whatever JITted code threads in the middle of running the AVX enabled one. The OS wants to switch them, but you know you got two versions of code floating around. And moment by moment, the thread will be running one or the other.
Right.
And that goes all the way down to your ELF file format, right? Once you patch your, once you patch the GOT to have one version of that thing, you now need two copies of everything, one for the efficiency core and one for the non-efficiency core. Like it's just a
yeah, wild.
I don't think Windows uses ELF yet, do they?
You know, there's other things like I've had versions of JVMs. I mean, I did version of JVMs that ask the question, how big is a cache line? By doing the appropriate high-speed probing. Having decided how big a cache line, that went straight into the fast path TLAB slab allocator code. And if you change the cache size on me, I will probably maximally negatively optimize your cache line prefetch for new allocations. Yeah, it'll go from whatever the good core to the bad core to the bad core to good core. One of the two will be totally inverted performance hit, you know.
There's another interesting thing, by the way, with Java, going back to the earlier discussion. Simon, you may find this interesting. I just remembered this actually because of one of the other links that got posted. So they tested restoring the JVM image from disk versus loading, parsing, compiling, blah, blah, blah. And it turns out that like well over 90% of the time was spent in IO. So it was actually faster in most of the tests to load from a jar again and actually parse it and verify it and look in their navel for a couple nanoseconds and then spin a wheel for a couple picoseconds. You know, like they did all this junk every time, and it was still faster than just loading a preformed image, which is
it's the ratio between memory and disk. If
right.
OS has got your jar file cached, that's pretty quick.
So now I haven't seen these tests myself, so I'm telling you secondhand from.
Yeah, you have to try it with SSD drives now too. So there's another version of that which says that we'll pull your fast image from an SSD drive. I know that the high frequency trader crowd pays big for non-volatile VRAM things so that they can do basically instantaneous restarts for that kind of stuff. But that's not a common, I had to set that up big time, a lot of effort, and paid big money for that hardware as well.
Yeah, so when we first, so I ran a hardware product at Oracle, and when we first rolled it out, we had 32 gigabyte flash drives, and they were $10,000. Yeah, so it's come a long way since then. That was only like
Yeah,
10
but
years
the
ago.
concept remains. There's still, you can pay money for this fast thing. The default thing is, fast or slow or whatever. But memory's got more bandwidth now, so the cost to page in a couple of gigabytes of a shared jar file from OS memory to user space, it's not that much.
Yeah, to your point on the verifier, one of the hacks we did was to change the verifier not to load classes that hadn't been loaded yet. It just records the relationships that it would have asserted and does that later on. And it's all because the win is out of not loading the classes at all. If you have to load them, and whether you verify them or not, there wasn't enough of a win to be
Yeah.
worthwhile. You had to have some hack to not load the class.
And we take the very opposite corner of that two-dimensional graph in our approach, which is we close over the whole type system. So we don't try skipping loading any of the classes, because you get a lot of optimizations possible if you have
Closed world.
Totality and whatnot becomes easily provable, and you can close over the whole.
Is that a startup time cost or is that a compile time cost?
So it depends how you define it, right? So it's not compile time, but it's not runtime. It's somewhere in between. So we call it load and link time, but that can be done well in advance of start time.
Yeah, the JVM internally has a load and a link step, and class files go through these steps all along the way to running, getting to where they're going to initialize and go. But you can be loaded and not linked, and you can be linked but not initialized. You can start your CL init and have to do jitting because the CL init runs high volume, high frequency code that wants to make new objects inside the CL init and shit like that. And then the CL init's done and the class is official and blah, blah, blah. There's some other hacks that are brutally ugly in there, but there's definitely stages you go through. And yeah, I'm with Dan here. The fastest class file is the one that never loaded. It's a lot of shit to load it too.
Right, but if you can separate out that step,
Yeah.
You can verify as deeply as you want to because no one's waiting on it. So in a sense, even though you're paying the cost somewhere, it's still electricity, still CPU cycles. It's not measurable from a starting the application point of view, which is dramatically different than if you were doing, say, a REPL, in which case, every change goes the whole circuit.
What's the typical deployment model then? If we look at some of I was talking to somebody from Shopify, and they were saying they deploy, I think it was every 5 or 7 minutes, they do a new deployment. And so you start to lose the option to do some of that pre-initialization because you only have 5 to 7 minutes of time before you're going to have the next version come in.
We're talking seconds though, not minutes.
Okay.
So, because verification can be fairly deep. And then basically what you're trying to do is collect statistics over time. So you're going to have a pile of statistics from previous runs. Not all of them are going to be applicable if the code's changed. So you have to sort out which ones can still be assumed to be true. And then you're going to run an optimizing compiler across that. So it's seconds. Yeah.
Run optimizing compiler depends on the volume. It could be a lot longer than seconds. I don't know how big Shopify's launch, like a new one gets deployed, but are they deploying in a pipeline that has an hour of QA and continuous integration behind it? Or are they literally taking a thing that's never been started before and starting it up in 5 minutes and killing all the rest? Or you get a stretch that pipeline, you can stretch it pretty long, where you went from continuous integration through to some end stage, and then I kicked it off every 5 minutes. But I had a few thousand JVMs in my cluster, and I brought the old ones down after a while. And that shiny new coupon and sale, Black Friday, blah, 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 rolled through my cluster and didn't atomically hit it all at once.
Yeah, a staged rollout could take days.
You get a lot longer. You could be imagining a new JVM with new code shows up every 5 minutes, and also an old JVM that was continuously up for a while. The last one of those went down after a day from when the new guy showed up, and that's the turnaround time for changing 100% availability of whatever is going on sale at Shopify. I mean, I don't know what are they changing it for. You know, if they change some fundamental interaction between the front and the back end, everyone has to change it once and all agree to it. Okay, that's one story. If I'm just rotating coupons through because I'm changing what's on sale and what's not, a little slow, a little big, a little fast is fine.
And we do have some cases that'll be more than seconds, because on the we have an NP complete issue, and NP, we've got one of those problems in our linker.
Oh, in your linker?
Yeah, well, it's has to do with we have to form a graph across multiple modules, and if the versions aren't specified, we have to prove that the versions we select will fit with each other. So each module contains all the versions of that module that are still supported. So you may have, let's take the Spring example from Java. You may have a Spring module with 600 versions in it, right? Plus some betas that haven't gone out yet, and some so all in one module file. Right now you have two of those, you now have 600 times 600, right? You have three of those, you now have 600 cubed, right? If you have an NPM style deployment, like I'm working with React right now, so I installed one NPM module. I kid you not, I have 3,000 NPM modules on my hard drive now. I installed one. Like Mark actually, he's not here today, but he actually
done that.
It's like, holy cow. Like,
yeah.
So imagine you have 3,000 modules, each one has 3,000 versions, right? Now, how do you,
they usually have one or two, except a couple guys have hundreds, but most have just one or two. But I hear what you're saying. You're saying there's some try them all against them all.
Yeah, I think I described this to you before, because I actually wrote a hard,
this is what
it has some optimizations, but it eventually drops down to a Boolean SAT.
This is why you want to do the lattice thing.
This solver theory, I can't remember.
Yeah, SAT solver. And yeah. Satisfiability. No, this is what you do the lattice thing for. You get guaranteed linear time and actually pretty quick result, but you need to have a little bit of extra information across your modules that demand that there's some ordering between them. Like A subsumes B, subsumes C, subsumes D, and it's not the case that I can pick one of B or C and they're all a little different.
So you're talking a directed acyclic graph then?
It can be a little more subtle than that, but you end up with a DAG, yeah. And then everyone's got a DAG, and now you can walk the DAG across everybody all in parallel at once and come up with.
There's one thing you can be certain about with open source projects is that there's no acyclical to it.
No, I know. As I'm saying, when you build your module, some guy says, I have this module I want to put in. I want to put this version of the module in. I support this feature set. I support that feature set. Big overlap, two little pieces of exceptions on either side. I say, one of you guys gets to lose. You two, here's knives in a small room. The winner gets to go in, the loser does not. Pick your poison, and that's the supported version. We're not putting in both incompatible versions. And if you happen to use this set, you get this guy, and use that piece, use that guy. And if you use neither, I don't care. And if you use both, you're screwed and you can't be done. Right? And you don't have the and it can't be done version. I don't support that. No one writes code that uses both halves of the incompatible versions of the module, or you don't allow people to do that. Right. I mean, I know due to dependencies you can.
Since we close over, we're not going to load like two different versions of the module.
Yeah, you're making the call
in the same type system, right? So the type system will we have to pick one version of it.
Yeah.
And when you mount a module into another module, you get to indicate which versions you want to avoid, which versions you allow, and which versions you prefer. So you can explicitly say, I don't want to use that version. And it's actually, when I say version, it's a version tree, because all versions are hierarchical too.
Yeah.
So you basically say, I allow this, I avoid this, and I prefer that. And you can have any number of those clauses. So basically what you're doing is you're taking the set of available versions versus the set of imports of that module.
You have to optimize your
constraints. And then you're trying to, right.
Yeah, now you have a problem that can't be done. conveniently, and in fact may not have an answer for a particular set of constraints.
Right. So what we'll do is we'll spend a couple seconds on the problem, and if we can't figure it out in a couple seconds, we'll basically give them an error and say, you need to tell us which version to use. That's your room with the knives. I
Right.
guess.
Okay. But right. But and hand in hand to that is, we're not going to, how do you describe to the end user why you can't make a decision? Well, I wanted to use version A because it has this little piece so I could support this guy who calls this guy who needs that little piece, or this and this and this, and you have some very complicated set of constraints of which they all mutually conflict, but no pairwise.
So I think what we'll do is throw the quantum computer not available exception.
Yes. Okay. I'm just claiming that it might be useful for your end user experience to not go there and instead say, you have to like nail these things down in an order that are mutually more or less compatible. We'll allow skips, and this one's no good now.
So the main problem isn't the application developer. The main problem is that the application developer used two different modules that are both handy, both well tested, both run great, but 17 levels down their dependency graph,
right?
They have
mutually incompatible.
Mutual dependent. Exactly.
Yeah,
exactly.
I get that. No, I'm saying if you force an ordering at the right layer, you can get a lattice out and then get a hard guarantee with quick time and a reasonable answer that you can tell somebody, I can't do this because this and this.
I look forward to tackling that problem.
But if you're gonna support it, you have to support it well, because if you load the wrong thing,
well, that's the same as my approximation problem. There's the answers that I have to have, and then there's the just don't suck. Right. And get it right, but I'm ignoring all your I prefer this and da da da. I'll just not get the don't do this versions in there, and pick from the yes pile and avoid the no pile, and then it'll suck for a while.
Yeah, I'll add something as well. And this whole design kind of grew out of issues I've had on other platforms and witnessed on other platforms. So the Spring example is a good one, right? So a lot of people run Spring with Hibernate, but they don't just come from two different companies. They come from two different companies that hate each other, or used to. I mean, back in the day.
Yeah.
So you got two companies that hate each other, and some people use one, and some people use the other, and some people use both together, right? And then each one has a tree of versions, right? And then, at the time, the answer from the Java team was, well, they're all downstream. So there's either the JVM and its core library, or it's downstream. It's Boolean. And it's like, no, there's a big difference between writing Spring, writing Hibernate, right? That's kind of a different tier than writing the JVM, which is a different tier than writing the app, right? So it's like, there's at least 3 discrete use cases here. And Java's like, no, all we have to solve is the JVM and the core library and the app. What about the libraries? Well, that's the app's problem, right? So it's like, it's either in the JVM or it's someone else's problem.
That's right. I was there. That's the correct answer for a company trying to make a product that's going to buy them hardware sales, but not money otherwise. It took off, caught fire, but they solved a subset of all those problems. And I kind of agree that that's the set of problems that, they should have cut the line somewhere. And I think they did a reasonable job at it.
I think they did a brilliant job for what was known 26 years ago. They did a freaking brilliant job, but we've had 26 years to think about it. So
fine. Now what you gonna do? I don't know.
So we'll
haircut, man.
To pull the AA card.
Yeah. Fine. You wanted to hear the AA? What the hell? Yeah. I almost came up with an example to show people what my yak shaving of the week is about. It was like I got my approx working in all the right ways except the do not suck way. And for the couple of people who haven't been on a call in a while, I'm running this type system theory thing. I have a large lattice of types. You can grow a type the same as you would grow an integer range running around a for loop, where at the start of the for loop, you would say I is 0 and the range of I is 0 to 0. And you run through the loop and, oh, it's 0 to 1. and you add 1 to 0 range, 0 to 1, you get 0 to 2, 0 to 3, 0 to 4. Like at some point you have to stop doing that because you'll be forever to get to 0 to N64. So you have some shortcut that approximates the value, says, I give it up, you're fat. So I had the same theoretical concept in running around with structures and functions returning structures and various versions of the same here, where when I run through this recursive loop, I add a layer of a linked list onto another linked list, and my links grow longer and longer. And at some point I want to approximate this and say, stop this, you're just making a cyclic structure where the payload is the union of all the payloads I've seen or can ever see, but the links are just self-recursive or nil. Okay, fine. So I need an approximation function for structures. It's pretty straightforward. And I want some properties out of it. And one of them is that if I approximate a value, it has the is a relationship between the original type and the approximated type. And if I have two types and they have an is a relationship between them, their approximations have an is a relationship between them. And of course, the other property I want is it actually approximates it. It prevents endless growth. Doesn't have to shrink, but it has to stop growth at some point somehow. And then the last one is it doesn't suck, because there's an easy answer here that says, I'll just throw all my types to bottom, and that's both shorter and approximates and quits growing. Well, okay, so I want something in between, shoot them all to bottom. And I had a good answer, I thought. And then I came up with a trivial case that's sort of not avoidable using my basic theory of I'll approximate by saying, if I see the same structure allocation happen in a row on my linked list trail, I'll cut you off after so many versions of it. And I could, give an example. I probably can give an example in the code here of depth 1. Let me pull up. This is kind of a fun, like, this looks like it should be obvious, and then turns out that it's like fucking not obvious, and you get
We
sucked.
can share screens.
Yeah, I'm trying to get to the share screen even now. Let's see here. Okay, share screen, people off to the side, code block. So I have some type, let's call it T1, which I claim is some structure, and I'm doing this from top of my head, so I'm not going to get it right, which is some end of a linked list and some value field, which has something like 17, I don't care what. And then I run through my loop and I get another version of T, which was at this. Oh, and I have another nested version, which is n is nil, v equals 17, and I have v equals, ABC here. And let me go and indent this a little lighter. And I'm growing this in a cycle so that the thing just keeps getting bigger and bigger and bigger. And I want to stop and approximate. So if I look at T1 and I say, give me an approximation, so let's call it AX for 1, and I claim I don't see the same allocation more than once, so I'll just call it that. No change. But if I look at AX number 2 and I say, oh, I see I have an approximation. I have the same structure appearing twice. So I want to make a closed cycle for n. I'll use a $sign for I'm cycling back to the AX2 type. And V is the approximation of 17 and ABC, a fucking Java object, I don't know. And I get this. And now I want to ask the question, is T is a AX1, T1 is a AX1, and that's sort of easy. T2 is a AX2. That turns out to be fairly straightforward because the way you define these things, is that there's no path that you can take through both structures that doesn't hit a point where they fail the is a test. So if you cycle a path from T2 and AX2 to the first step and you get nil or $, which I guess I'll put $question mark because that could be a self or a nil. And I see a nil, then I'm is a, and if I run T2 on himself to AX2, I'll see a structure where I would see a recursive thing. That's okay, but now I have to recursively check my path again, and now I check, and of course, I end up with nil or not versus 1 and the other, and of course the V's are always less than object, so I'm okay there. And then I want to know that my guys to see I didn't get the right version here. There's a version here where, right, so the failure is that V of object could also be below another type which has a recursive thing in here. Let me see, I'm going to blow my example because I'm writing it live. I don't know what I have for in here. V equals, oh, V is exactly one of these horrible things here. And this is what it might be. Is here. What am I doing wrong here? Well, in my example, I want to claim that one of these guys is high and he doesn't need to be, and I'm going to get crushed. Well, I don't have this example. I should have wrote the example down before I started this because I have it in my notes somewhere. What happens here is that the approximation version might bring in a new guy who loses the approximation and he grows. But if you wrap him around, he crushes somebody else in a way. It's right here. Maybe if I have an example. He crushes somebody else you don't expect, and suddenly you have to force. Oh, I forced V to object too soon. And then the example is I don't need V to object here. It's this example. I have it in my notes, in my comments. Here's why this sucks. Yes, okay, so if I start here with, where am I gonna cycle on? I'm cycling there. So this is, I'm gonna call this is any. I don't know yet what it is. It's any, it's the good side of any. And then if I loop you like this, and if I meet your approximation here, you're going to keep that. If I meet this approximation here, oh, I can be a string. And then what's the failure mode? Oh, because I can't go to, when do I lose it here? Because I have to have another depth already. Where's the third piece? It's inside this guy here. Nil, and I wrapped you once. Yes. So the failure here is I already lost what I think is my next chain is going to be. And I have a value which is something high. And then the second wrapped guy says, this is, yep, okay, here we go. And so this is why I should never do these live demos of this shit here. I want this guy to be, oh, I see what I'm doing here. Now I reverse myself here. That should be down here and it's any and it's object. The nested guy says also any. And the interior nested dude is saying, I have, I don't actually care what this value is. And this guy becomes equals, oh, it's n equals, you know, some object, some horrific thing. And if I would approximate number 2, I make no change. We look at approximating number 1. I don't trust my example yet, so you know. I fought through this last week and or this week at the start of the week, and I haven't looked at it once I got past it here. Oh yeah, what's the approx here for this guy? So the T1 approximation wants to come around and say, I can cycle myself twice. Is that correct? That it didn't do this right here. Hang on, I don't have this right here, but I'm getting closer. Maybe I should just stop on behind. So I have 2 versions. Now they're hung all, I have 3 actually on V, and I'm cutting it down to 2. Cutting it down to 1, which is probably sane. And I'm claiming pred should have been V, V should be pred. I'm renaming in my head as part of the issue. So pred should be V. So this pred should be any as well. And that means success is in. That's what's going on here. Oh, the nested guy has success, which is in. Yes, which turns into a pred, which is a V, right? And then the V internally has a success, which is like fail out. And I claim that's correct. Now, why am I not getting a reasonable approximation here? Oh, because I've got I need to say, like some comment to myself here, or I'm going to blow this. vpred here. I have to alternate back and forth, and then suddenly you get the bad answer. And is a nested guy who has a v, which is a nested guy, which has an n, which is bad. And then when I approximate the guy with the v here, it's high, so he can just live with the approximated version. In wait, no, the approximate says it should be recursive as well. Why is this looking weird to me? Because I don't have it indented well. And I bring that around, and he approximates there. And I bring that around, the v drops to any, and he should be this. vpred, pred successor, scalar. I claim this is what I got for my example. Let me kill this here for a second. And the obvious fail that in this example is that AX1 is not is a AX2 because V as a recursive thing is already below V as any. And if I look at my where's my is a test here? Now I have this one backwards. Why? Oh, because this should be, one of these is high, and yes, oh, high and low, I'm backwards there. Fuck it. Maybe you get the concept. I've already been like 10 minutes at this. Okay, 5 minutes. And I need,
Okay.
need to go write this up. But the point being is that somebody gets approximated too strongly. I still believe my notes, so I should just cut and paste my notes in and probably be a lot easier than trying to write short. In fact, once I grab my notes, I probably should just do that. Now let's see if the Google later loves me here. I have some extra junk in the notes that doesn't help. Let me go clean this out, do it this way. The bracket 12 is just the unique number that indicates I'm repeating the same structure recursively. And I need to be wider because I'm getting wrapped around and somebody's tabbing didn't like me. So let me do, oh, I see. Oh, there's a freaking tab. Yeah, okay, so I got tabs thrown in by somebody, I don't know who, instead of spaces, so the indentation is poor here. I'm trying to make a 2-column operation. And where's the wrap for this guy here? That guy is that guy, this guy is this guy, that guy's that guy. Oh, here it is. This guy needs to come back in. Okay, that's first version. And then I have the approx version here, which probably indented a little nicer, kind of, sort of. If I believe this, other than the indentation being horrific. Oh, because it's fucking tabs everywhere. Yes, I mean, it's tabs. Okay, so something like this going on here, where the top left corner, so I have a 2x2 table. The top left corner claims it is of the top right corner, and that's because, I'll get rid of my n's and v's. I added them while we were talking here in a way that, look at that, look at the tabs. Because, and scalar, you can consider twiddle scalar as like top and scalar's bottom, or as capital scalar be capital O object and twiddle scalar be some sort of anti-object from the top of the inverted top of the universe, can fall to any value. So going left to right from the top set, I have a structure that has number 12. The 12 is just unique everywhere, so you don't need to see the 12 at all. I have a structure that's replicated on the right, but now I didn't view it field by field. I have 2 pred fields that are both twiddle scalar, so those are equal, so that's an ISA. I have a successor field, which is some structure, and I don't care what it is. On the right, I have a successor field, which is scalar, which is max bottom value is always below any other value. So it's totally an is relationship going left to right. Going top to bottom, I want to approximate. And so on the right-hand side, there was no repeats of 12, so of structure 12, so I can just do nothing for the approximation, and that's legit. For the left-hand side, I have a nested replica version of 12, and I want to turn it to a cyclic structure. This is my linked list going on for forever. So I want to move the first nested layer in over the outer nested layer, the outer layer that's not nested, and I discover I have another recursion going on, and I can cycle the recursion here and say the two versions are both self-recursive. And now I'm staring at a thing that looks like a bug to me in my approximation in my notes, and I'll feel stupid if that's the case. But on the bottom, the two approximations are definitely not ISA, because the recursive successor, I'm sorry, the recursive pred field is below the scalar, the twiddle scalar field, because twiddle scalar is the highest possible value. So it fails the ISA test. So what it comes down to is when I make a cyclic structure, when I take the infinite chain of successor fields and wrap them on top of each other, I can crush a field for which I know I have some very good answer to some very weak answer, and that blows my ISA property. And it blows it in a sort of a trivially easy to produce way at the very highest levels, and I get a bad answer out. And there is a better approximation out here that doesn't blow my pred as twiddle scalar. And that's what I was sorting out Thursday and, well, Wednesday and Thursday. So I claim this version, which counts the number of instances of the 12 structure appearing, says you ran over my count limit. Oh, that's what happened here. I kind of counted it there. And then because I ran over my count limit, I forced a widening operation on you by wrapping the nested deeper guy on top of the outer guy. And then furthermore, unified all the aligned fields that come from that. That gives me a cyclic structure, which works great in a lot of fun cases and fails in this sort of trivial case because it loses the outermost pred value. And then suddenly I'm not monotonic going from left to right. So that was my yak shaving of the week. There is another version of Approx which does it correctly and loses the value. This example is losing the value, is not being correct because I lost the nested twiddle, the nested full scalar. I have the corrected version with an example. I need to fix my example in my notes where this still happens on me and I need to do something a little different. And the real answer is I don't need to, I can't just cut you off after a fixed count. I have to cut you off if I see that you're not making forward progress in the types, because there is a finite bound to the lattice and you'll eventually hit bottom and stop making forward progress. But that means that I'll arbitrarily maintain precision up to the depth of the lattice to see unique values that are strictly lower for like the value field. And eventually I'll hit bottom there and keep the precision where I want it. Anyhow, that was my yak shaving for the week. I blew a non-monotonicity assert on only the most largest horrific test cases. I've spent much of yesterday sorting one test case out and fixing it, doing something I thought was right. Now I have a different test case that's not quite right. That's also horrifically huge. These things take a fucking hour, 2 hours to debug each one. And it's the only fail I have out of several hundred tests. So I kind of claim that, you know, I'm closing in on an answer. I'll have it at some point and I'll have a decent approximation that will also preserve values. You know, it won't suck. It'll have all the right properties and won't suck. And that will give me my good type. So let me show you where this is coming from as the example here, where you get a good answer out. So you can see maybe the difference between good and bad answer here. Here's a non-indented piece of AA code that represents, let me indent this code, however you want to do it. It's actually the core language AA, which is a type lambda calculus for all intents and purposes. So this code says map is a function which takes a function on list. If the list is nil, return a nil. If list is not nil, return a structure which is formed by making a next one field of mapping of the function with the list of the next zero field. And the value comes from applying the function on the list of zero to make a list of one. So that's the code. And the obvious thing is it's supposed to be, I'm just infer the type for this guy. And I get two different types. I get a Hindley-Milner type, which is this one. So the Hindley-Milner type is called HM type. Looks like this. It's a struct which has two struct. It's a function which takes two arguments. One is a function from A to B. One is a type C, which is a self-recursive type, taking v0 and ... means extra fields, and it's nillable. And it's a function, so there's an arrow, and I'm indenting types, and that's kind of horrible to read. And it returns me a struct that's got in one field, which is self-recursive, nillable, and the payload's always B instead of A because I mapped A to B. So that's that's half of the inference. The other inference I'm getting out of here is the pretty print on. Actually, I can do that by doing this. Let me stop this. Let me go run code here and get. I don't have a pretty printed version. I have the in-readable version here. And that's because, why are you stop, halt? No, God damn it. I have issues with too many windows open for trying to you're not seeing my debug. Here, see if I can run this now. Yes. Did I get this? Here's a reasonable, oh, lost my sharing window. It is this. Okay, so this is the flow type, which says it's harder to read here. I'm ignoring inputs on the flow types. I'm just looking at the output. It says any kind of a function at all. So this is all function pointers, all function identities. I'll get rid of it. So the function takes something for an input argument, which I'm ignoring, and one of them. And I'm returning back. It's actually should be two. So that's the off by one bug. It's sort of inconsequential. You don't care about the hat field. So it's just this. And the blank here is actually scalar. And this just says, I'm returning you a structure number 5 or nil. That's the 5 or nil, where the in1 field is a pointer to 5 or nil. And V is a scalar. He doesn't have the relationship between inputs and outputs because the flow types are there. But I do get the self-recursive instance on the in1 field pointing to itself. So this is a point where the flow types grow endlessly as I walk around the recursive cycle. So I approximate, I get a closed cycle out, I get what I want. It gives me a payload. And of course, scalar is my shortcut for whatever the fuck you passed in for a function from A to B. Whatever B is, it's whatever you passed in. It can be anything. That's why it's a scalar here. So I want this type out on the flow side. That's what I'm trying to get out by approximating. It turns out that in practice for very large, complicated things like I do, I'm not showing you examples where I have like piano arithmetic written in types. But in structures of functions, I compute piano arithmetic, and now I'll go type this thing. Well, the Hindley-Milner types have come out with something kind of sort of reasonable. The flow types came up with some horrifically bad answer, and then they blew an assert at some point as well. So that's where I'm at. Once you get your head wrapped around the types, they're kind of fun to play with, or I'm having fun playing with them. But I think I'll have a solid type out, hopefully by the end of today. And this will be the last final failing test case. And I'll declare victory on types once again until we meet again and go back to making things happen elsewhere. So I hope that hurt everyone's head appropriately, and I'll be done sharing here.
So is that like a promise that, if you encounter another type error, you're going to stop developing AA because it's just too frustrating?
No, yeah, the type errors are frustrating. Well, no, my goal here is to show that I can do something sensible with forward flow types and Hindley-Milner for inferencing. Like forward flow types is what everyone normally uses for C and C++ and Java, and a whole lot of C#, and a lot of folks do this. And they demand types for every possible function everywhere, unless you fall into the Hindley-Milner, Damas-Milner camp, and then you get to do some inferencing. And I'm trying to say, and then the flow types gives you other typing properties that you can't get out of Hindley-Milner. And I'm trying to say, I want the best of both worlds. So I'm trying to get something out of my flow types but I need to, the issue with flow types is you have to give type annotations everywhere. So your Java programs have their functions are all strongly typed. And I wrote in my map call there, you see, I didn't even name that structure or type that structure at any point. So I totally deduced the type of that structure as being a structure contains an N0 and a V0, and the N0 is self-recursive and the N1 is self-recursive, blah, blah. I did all that sort of automatically at all layers. And I wanted to do that property, but to also then get I have a single best type answer, like a guaranteed principal type. I need to know that my flow types are monotonic and they'll achieve a fixed point at some point. So I have to have monotonicity out of them so I can get a guaranteed fixed point. So I guaranteed have a principal type. Yeah, so that's sort of why I'm here. And you know, my claim is the theory is sound, the practice has issues that I'm working on. So until I convince myself that my theory is not sound, I'm going to beat on bugs in the type system.
So
Usual story. Now the type system is
like the paper on the theory though. It's just
I'm sorry.
You don't have like a paper or something on
No,
the
I don't have
theory.
paper on theory.
Like
No.
some little notes.
No. This is me doing my thesis work, combining optimizations, combining analyses, where I've taken DeMoss-Milner or Hindley-Milner and declared it to be a monotone analysis framework. And then I'm combining it with another monotone analysis framework, which is flow types. Turns out that I've vastly extended both of them in other directions as well. So my Hindley-Milner will support knowing that you have tests that are known true or false, and therefore they don't have to unify both arms of an if statement. And he will have ground terms that are based on the lattice side, which can include integer ranges and not just int versus bool versus float. And there are like 3 other things that the Hindley-Milner side picks up. And the flow side uses Hindley-Milner to improve like a function from A to B. He doesn't know that function. He can't infer the relationship between a collection of A's and a collection of B's and a function from A to B, which is what Hindley-Milner will totally do that inference. And flow types will not do that, known theoretically, but by merging the two, I can make them pick it up from the Hindley-Milner side. So both flow types and Hindley-Milner types virtuously feed into each other. And this lets me type programs that you can't type either side because they're, you know, they'd be unsafely typed or whatever. So now I don't know if that's a terribly useful thing. It looks fun, it looks useful. I want to find out. So that's the typing system that, you know, core wants to come out of AA. And when I get it right, I think it won't be hard to use, but it may surprise you at what things it will accept as well typed versus what it will fail out on you. You know, it does obvious things for obvious cases. And then there are some less obvious cases that I can infer my way through that either alone can't.
Yeah, but what I'm saying though is you don't have a proof on the theoretical side that your computation is.
I do.
You do. Okay.
That's what I said. I'm doing my thesis. The only wonky theory side thing is that I have treated Hindley-Milner as a monotone analysis framework. That is unusual. And to declare it as a monotone analysis framework, I have to find what it means to be monotonic for Hindley-Milner. And the normal execution of algorithm W types monotonically grow. Periodically, they merge and become unified, but the leaves only ever become non-leaves and you grow to some finite bound. Okay, so as soon as I claim you're monotonic in this way, I can declare you a monotonic analysis framework. I have to now make a bunch of proofs around the transfer functions, what it means to call if or function or application or add or whatever. That's the same thing you do for the flow typing, where if I mix an int and a float with an add, I know that there's a rule that says I widen the int to a float and I get a float out, right? So that's the same kind of transfer function. I have to do those. You have to do them for every primitive, for every application, every function, da, 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 da. You can get it wrong. They're big and complicated. Okay. And there's a lot of them. They're mostly not too complicated, but there's a lot of them. I've done extensions to them both. I can get those extensions wrong. Like, I think 2 weeks ago, I talked about having to do errors that were the same error everywhere. And everyone agreed. So you got a single, the principal solution included all possible error cases, and you got a single best error out as part of making this problem be tractable or whatever, provably correct or something. So I don't stop when I get a type error in Hindley-Milner. I don't abort now and say, yeah, mission failed, I can't unify X and Y. Instead, I have to claim, well, I want to unify X and Y, I can't, so let me carry on anyhow. And I'll do X things to X sides and Y things to Y sides, but X and Y, and one's a function, one's a struct, I can't unify them. So you'll get an error report in the end, and you'll get the same error report no matter which order I visit and how I approach the problem. There is a principal error message. So that was a funny, unexpected side consequence. I had a side consequence of, well, I want a nil that is well understood in the lattice in all directions. And this required me to understand integers that were nillable or not, floats that are nil or not nil, 0 or not in the float world, as well as nillable for pointers and everything else. So there's a canonicalization of nil that had to happen in places that you probably don't care, and they won't impact you in your usage cases. But to make the theory work out properly, I have to know that this float cannot be nil, or it can be nil, or I don't know if it's nil or not. Or I have to have all four of the, I know it might be, I know it can't be, I know it may be, I don't know. And then the theory works out, it's all good. Yeah. So that same sort of notion shows up every time I play these games, like the if thing for Hindley-Milner says I don't unify you unless the predicate becomes true or false, or goes to a bottom value, an unknown value, and then I have to unify both arms. But it also means that if I don't know yet, and I'm beginning the analysis, I don't unify either side. So, the if is left as a Hindley-Milner leaf, as an untyped thing until the predicate drops from unknowable into it might be true or false, or whatever it drops to, and then it usually drops to bottom and you get both arms anyhow. But if you have a constant there, it doesn't drop, and I have test cases for that. And I can totally type shit that you look at and say, no, this would be a type error. No, it's perfectly safe. So that answered the question?
Yeah, I mean, I don't know. I was just looking at your example and thinking like, well, what if recursive was actually scalar, or what if, why isn't scalar?
Well, let's go. I mean, I can go correct the test case here and step you through what it means. So this is on the flow side, not Hindley-Milner side. And I want the properties of monotonicity on approximation so that I can freely approximate and guaranteed still close in on a principal answer. And I have to be monotonic both across and down so that it doesn't matter what order I apply approximations, I'll close in onto the same answer. That's part of the rule, and that gets to the principal type theory. So I can then show you a 1950s paper that says you get a principal type out. That was the basis I started my thesis from.
Okay, so well, going back to the example, so you said that recursive is a twiddle scalar, and so that, right?
Yeah, because twiddle scalar is above all things.
Okay.
And
if it's above all things, then you'd think recursive would be a thing as well.
Recursive is a self loop. So it effectively lands in the center line of a constant propagation lattice. So imagine a constant propagation lattice using normal integer constants. You have some top, you have a bottom, you have 0, 1, 2, 3, 4, 5 as your constants. The 0, 1, 2, 3, 4, 5 are on the center line. And there's something above and below that you just cap. One says, might be any constant, the other says, I don't fucking know, I have to compute it. Okay. In the land of structures, there is a funny deal where a self loop doesn't make you more or less than anything else other than the same self loop again. So this gets into what it means to have a cyclic type. So if you look at all these papers about how to do these type theories and things, they immediately complain we don't do cyclic types because it leads to difficulties. The difficulties are fairly straightforward, other than the coding is like nasty to work with cyclic types. Like you can't use structural recursion. So up until I have cyclic types, all things are done with standard structural recursive building. If I look at two structs, I want to know, are they ISA? Well, I ask them field by field. Fields internally ask recursively, field by whatever, functions check their returns and yada, yada, yada. You get a standard structural recursion. As soon as you have cycles, you have to play a different game. So the algorithm's complicated, but semantics are pretty easy here. A self cycle is neither above or below anything else. It is a center line item. And you have to ask some other field if this structure as a whole is above or below.
I thought the whole point was that a top type is above everything. So when you're saying a cyclic type isn't above or below a top type, then
No, it is below a top type. Imagine a cyclic type as just being unrolled endlessly. It just unroll it in your
Right,
face. Right. Okay, so it says I have a pointer to a 12, which is the next field which points to 12, which is the next field which points to 12. Okay, then the other one I have is I have a pointer to 12, which has a next field which is that twiddle scalar. That's above pointed to a 12. And that's the reason those two are above or below. So if you're looking at the outermost structure on the both sides, they say I'm both number 12 objects. Okay, now I have to ask field by field. I go inside, ask the pred field. One says I'm a twiddle scalar. The other says I'm a pointed to a 12. Twiddle scalar is above a pointed to a 12. Those two are ordered. Therefore, the two structs are ordered. You back out the recursion layer, the two structs are ordered. So those are ordered. It's the struct with the recursive self-cycle. That recursive self-cycle never breaks a tie about who's above or below. It never breaks a tie. You have to go ask somebody else to break the tie. Okay. So that's what I meant by it's on the center line. It's not a tiebreaker. Ask somebody else.
Well, I'm still when you go from the top left to the bottom left.
I have an error there that I showed because I got it out of my notes because I didn't get the example quite right. So this is like take time now to fix the example, and this will fix confusion. It's like better to not have an example at all than to have a broken example.
Okay, so the example is still broken.
Yeah, and the thing that I was doing was I was cut and pasting bugs where I had my depth where I allowed a cutoff to vary from 1 or 2 or 3. And I had mutilated the 1, 2, or 3 where you roll the example back onto itself. So what you would normally do here is actually here is probably the fix. This will fix me. This is not necessarily what I wanted to say, but this will fix the example. It actually fixes it okay. So you take I'm going to call the 12s in the first top left corner. I'm going to give the 12s furthermore an instance occurrence. So there's a .0. Here's a .1. When I do the approximation by claiming I want to fold up the double nested versions, I'm going to lay 12.1 over 12.0. And so my answer down here is 12.01. But now I have to lay the fields that are inside 12.1 over on top of the fields that are in 12.0 and field by field approximate. So in the case of the pred field listed there, 12.0 has a twiddle scalar that's above all things. So 12.1 wants to say twiddle scalar success equals scalar, except he also has to be he also has to close the cycle, be recursive. So he ends up being recursive, and then I have to go again and say suck equals scalar overlays suck equals 12.1, and that falls to scalar, and you get this approximation here at 12.01, which still fails going left to right because the recursive example is not a twiddle scalar.
It doesn't seem right to me.
Yeah, I'm with you, and I'm staring at it myself here. I know that the theoretical piece is I want to declare suck for 12.0 sucks to be a recursive self cycle, and then overlay the contents of 12.1 over 12.0 and unify, do lattice meet field by field. So this would give me a version that said, I'm going to hack again here. This would be recursive, except I now have to also lay over the contents of this pred, and there is no suck field here. Okay, so this is what probably the confusion is. Let me fix this here. I didn't do anything for here because it wasn't part of the example, right? So now I lay over those two fields. So pred lays over and becomes pointer 12 with, you know, this. Right. And let me get rid of, let me align my two columns correctly here. But successor is recursive meet this. Right. So if I put this to being successor here, now the scalar here, sorry, scalar here, the example is complete because this meets scalar here, scalar like that is just scalar. Get this example. Okay, now I claim I think this looks more like the example I intended. So you roll 12.1 over 12.0, you meet twiddle scalar and the nested pred field, and that becomes pointer 12, success equals scalar. And you align the nested 12.1 scalar over the other one. And yeah, this is it. So I think what happened before was I was nesting the second innermost 12 over the third innermost 12 over the second innermost 12, 12.2 over 12.1. And here for this example, I did 12.1 over 12.0. And that's the reason the example printed out badly. But this example is now consistently broken. And in fact, I can simplify it here by replacing this with just a 17 or a pi. And you get this. This is probably example. It'll be easier to read here. Okay, so now you get this version of things. Yeah. Boom. And you lose the self cycle, but you didn't really have it in the first place because you didn't have a looping thing going on. It was just two layers, and I declared two was too many, so I wrapped it. And this fails. So let me go actually.
Okay.
Yeah.
So the issue is that you didn't take the higher of the two pred planes.
Yeah. But it's because I was wrapping. I took an example that was wrapping a third version 12 over a second version 12, and I tried to make it a version that was a second version 12 wrapped over a first version 12, or 12.1 over 12.0 versus 12.2 over 12.1. And so the example would work out. Yeah. So my apologies for that, but that was, live example. That's what happens. You get a live example going. Anyhow, this version is a buggy. I have a version that's not, and then I have to have a version that doesn't suck. And it's not buggy. I mean, it doesn't have the properties I want out of it. It definitely approximates. It definitely is a from top to bottom. It's not is a going left to right, which I also want that property. Anyhow, I have, like I said, I have much more aggressive testing now for these things going on, and I'm down to like one really obnoxious test case that I've blown something going top to bottom, not left to right, for a hugely deeply nested self-cyclic thing. And it's the cycle math implementation that can lead to bugs. Because in addition to doing cycles, I want to do them efficiently, and I should give up on that probably. So the obvious way to do all the cyclic structures is to just unroll the fuck out of them, then do a structural recursive meet, except it would be infinite otherwise, and let them unroll long ways, and then stop, and then look where you got repeated unrolls and like roll it back up into a cycle. That would be sort of an obvious way to solve it. That's the algorithmic, that's the answer you want of the algorithm. The efficiency you want is you want to do this in one pass. That's the smaller of the result and the inputs. Right now, the structural recursive meet gives me an answer that is the smaller of either input and the meet. So it chops aggressively as necessary, and therefore it's quite efficient in that sense. Also, everything's interned, so all your cycles, once they're interned, you can compare a cycle with pointer equality and not have to do some sort of cyclic equality meet. So the interning step is like a bitch. But in this case, for this big approximation, I want to walk the guy to approximate, find nested instances of the type that I'm disallowing you getting too deep on, roll it back up the tree, the structural recursive tree, some layer, and meet as a way to prevent infinite looping. And at the same time as I do that, I would turn the point at the bottom, which I brought up, is a self cycle. And then this all sort of sounds reasonable, kind of. And then I sent you an example where it's a DAG that went, and then they have multiple cycles and epicycles and epicycles. And somewhere in there, I blew one of my "don't visit me, I've been here already" passes, and I failed to get a correct approximation out. Yeah, and then that's just, you know, I'm trying to get too clever. I should figure a way to do this stupider and easier. Yeah, the bitch is getting the self cycles. If I didn't have cyclic types, this wouldn't be an issue. And in fact, it would have been done a long time ago, because the recursive descent breakdown of types is sort of completely trivial to go do. You know, that one was working long ago. All the cyclic types is what the issue is.
Well, I know, I mean, Stephen Dolan thesis about with subtyping, I know he has recursive types.
Many people, no, cyclic, not recursive.
Well, I mean, they're almost the same.
No, there's yes and no. There's a world of hurt in between the two, and that's the issue. Let me give you the example. It's the standard example that people are happy to give up on. I got way up in here. Henley Milner gives up on it as well. This example, which, oh, Aaron dropped. Let me readmit him. I could throw this. Where's the Google Docs? Okay, so what's the type for this guy? It's a function which takes an argument f and applies f to itself. As soon as you ask Henley Milner, he says, "Hey, you get an occurs check, and I throw you out. I blow you up on you. You go look at algorithm W. There's an occurs check, and you're toast." If I look at the type for this that I get out of this, and actually other people do too. This is not surprising here. The type's really trivial. It's a function that takes some A type and returns a B, and A is, oh, the function itself. So that's cyclic as opposed to a linked list, which is recursive, right? This is a cyclic type. Whereas a linked list would be some structure which has a next field, which is typed as a list question mark, and maybe a val field, which has some type, some exciting type. That's a recursive type. It's not cyclic in that way. People do that one all the time with structural recursion. The cyclic type on the function arguments hurts you in a bunch of things, a bunch of ways. Internally, when I build that type, I do get a self cycle. And then I had to go enhance all the Henley Milner, the algorithm W, to handle them. It's sort of straightforward, but it's a pain in the neck. Same as I did it for the flow types in the constant propagation. The flow typing side has a cyclic flavor, and the Henley Milner now, mine version, has a cyclic flavor as well. And so all your structural recursive walks have to be smart, that they might hit a cycle, and they have to stop endlessly recursing down the cycle. So everything that says, take this guy and unify it with that guy, but in structural recursion on Henley Milner, the algorithm W says, okay, I'm doing a unify step. Well, I have a function. Unify the arguments with the arguments in this function. And then what did it and you do the next, Okay, it's recursive, cyclic. So you just spin forever. You never bottom out, and you never get an answer out. You know, you stack overflow and die. So you have to go handle cycles there now. And so that's part of the pain in the neck, is the extensions. That I think that one's not, people have done that one. That's I haven't seen any papers on it, but I hear in comments from people about papers that say it's a pain in the butt, but I didn't see any papers on it. But you know, I worked it through. It sort of semantically, it doesn't have any excitement going on.
Do you have the Y Combinator in your test suite?
Probably. I got every kind of horrific thing on the planet in here. You should write me a Y Combinator. I should go look one up. I don't have it on top of my head knowing where it is directly. I think I grabbed one a while ago, but I don't know if it's still in here now, and it should, because that's an obvious one. And I would claim it should look something like what you get out of that F goes to F arrow F.
It's like, I think it's like that, something like that.
So y is declared to be a function which takes, so what does yf on the left mean? I see a lambda here. I'm going to replace you with AA syntax.
Oh yeah, let me. Well, it takes the function f and then it applies it to.
I definitely have examples that look very similar to that. I could go write that example even now if we get an AA syntax.
Yeah, I mean it's like the function that you gave before, except it applies an f in the middle, basically. So I think that.
You think that's it?
Yeah, I'll check Wikipedia just to be sure.
Yeah. Okay. I mean, let me cut and paste.
Yeah.
So this is
Okay.
outer F.
Yeah, that's the one. Yeah, that's what Wikipedia says it is.
Okay, so that's an outer F is a function which takes an inner X, a function which is an X arrow to F applied to X and X. I have to put extra parens around to get applications. This is in the core. It's not AA in here, it's in the core. And that and it applies it twice. Is that what I just read here? Yes, it looks like it applies it twice. Which looks like this. Let me go run this through, see what happens here. It says I can't type because I have a missing curly. In my example, where do I missing a curly? I'm missing one there.
Are you typing it to the doc? I don't see it.
No, I'm typing it into my IntelliJ debugger.
Ah, you're going to run it in the test suite. Sure.
I'm going to run the test suite. And I haven't got my curlies. Oh, I have two curlies I have to have because X is defined. No, I'm missing one here. X, where is one curly there goes to one curly. I missed here. Yes, I'm going to run this thing there. And then again, I missed the entire second function as a function right there. Is F, and I don't get any indentation matching on strings inside IntelliJ, which would be very helpful here, which I do inside Emacs. F arrow, X arrow, F applied X, X, X arrow, F. Okay, let's try again. He says, you still have a net missing. Where's my semicolon missing now? That goes to there. Why am I missing one here? So I'm dying in the parser for having missed semicolon somewhere. Args F of X arrow, F of yeah. That should be application F the body of that guy. Let me go fucking write this in Emacs and get balanced parens out of the thing. That one's balanced, that one's balanced. Why am I complaining here? No, I'm missing an application. That's what's going on. You're actually, the same thing actually has another application in there. That's what's going on. Boom, I get this for a type.
Can you put both the AA code and the type out?
I'll put the AA code here. I claim it's a pretty reasonable type.
Yeah.
This is core AA type, which is a subset of AA. See things here. Which is just a simple type lambda calculus. It has function and application and almost no other syntax. Structs. Okay, yeah, I claim we're getting the same type.
Yeah, it looks right.
Yeah.
So it works.
I kind of didn't didn't expect to fail there on that one. That was too easy, but I'll rename it and give it proper in my test harness and stuff. That's a good one to have. Fine.
Yeah.
I will say that's as readable in AA as it is in the lambda calculus.
Oh, yeah. Yeah. You know, the core AA is this is like 100-line parser or less. It's like a trivial parser. It takes a trivial language. The only other thing that you're really adding here is I have structs with records, but like question mark colon is back to being an if as a function. It's a primitive, and it takes 3-argument function, just like the standard sort of functional language guys do. But lambdas or functions are declared with curlies, and then a variable arrow or any count of variables, it not be single arrow, and then an expression, and then you have application, which is just parens. Yeah, that's Cameron making funny comments. Go sweep your igloo, sir.
Ciao, guys. Good to see
We're
you.
yak shaving for victory here.
No, it's looking good.
Yep.
Always
Yep.
always impressive when anything works with a type system.
Yes. What the hell? Many exciting things work in my type system. Only like a handful of nasty, the worst examples are failing at the moment. All these little trivial self-recursive things that are trivial, they all worked a long time ago. I can give you much nastier looking examples that I am having problems with. These examples, like, yeah, whatever. Okay, it's 12 o'clock, a little after. We spent a long time on AA types. And, and I claim, Alan, I have a strong theoretical reason why this should work.
Okay.
So
You just haven't written it down.
I have not written down, well, I wanted to get the proof of the pudding is in the eating, right? I wanted to get to where I quit seeing type failures and decided I want to go write something. So I haven't been in the habit of writing type theoretical papers like denotational semantics at all. So and my lingo is some 20 years out of date. So I would be a poor author in that the paper would not be readable by the modern community without me doing a lot of work on how to get the jargon right. And separately, me doing a lot of work on denotational semantics to get that set up right. I think that's not impossible to do. It's just a bunch of work. So I'm kind of not inclined to go do that work anytime soon.
That's a lot of latex code.
I'm sorry?
It's a lot of latex code.
Yeah,
usually
right.
what I see.
Well, and for a limited audience. So as soon as I get a functioning AA that can be executed, the typing system, the theoretical side of the typing system is a lot more exciting to a lot of folks. And I'm much more inclined to go do something. Yeah, I looked at PLT Redux. And I don't know how to do that because I don't know how to put a monotone analysis framework in the denotational semantics in PLT Redux. I'm not enough of an expert here. And I don't claim it's a good use of my time right now to go to PLT Redux. I saw that just the other day and was stared at it for a little while and was like, yeah, I spent a lot of time to prove that I cannot write what I want to write in it or not. If I get something out of it that it can be written in it, then it's very exciting. I have my answer for denotational semantics, blah, blah, blah. It's all life, happiness, and good. But I think 50-50 that it can't be written this way because I'm not doing a Hindley-Milner style thing. I'm doing monotone analysis frameworks over Hindley-Milner, and now it's very different. And monotone analysis frameworks, I know how to go right up on, and that's my thesis. And the lingo has changed, and I have to switch top and bottom around, but the concepts are by and large the same, and I would just throw down, and here I start with this as a standard monotone analysis framework, blah, 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 and here I'm doing some jargon changes, it's pretty standard, and then here's my extensions, and the extensions come in, waves. I have a bunch of extensions for both of those. The constant propagation side, I'm doing, ints and floats is pretty common. Structs is less common with pointers and aliasing. And alias analysis in there is very uncommon. I'm doing call graph analysis, even more uncommon. And then, of course, it's unified with Hindley Milner in a virtuous way. So there's interactions between the two that cause the end result to be better than either one alone. And that's where you need some hardcore theory to back you up.
So your next step is really writing the runtime and
Yeah.
code generator.
Oh, I so badly want to get to a point where I can fucking run code.
I mean,
want
it
to have
gets
the
interesting
types.
when you get run code, because then we can start writing the standard library and play games of, okay,
Oh.
what is in my language that I can turn into a library?
Yeah, right. And what is exciting? What is stupid? You know, hey, Cliff, this doesn't actually work well. Like, we can do it. It types, but like, fucking no. You know, that kind of shit's going to happen, right? And so,
I suspect once you start writing the standard library and
Right.
actually wire the thing into the operating system and peripherals and stuff,
shit will come around. Yeah,
the language will both get bigger and smaller.
right. Somebody will be very excited to tell me that your exception model sucks, and here's why. And I haven't sorted out my exception model, but I can believe that my first cut in exception model. Somebody said this already in this talk. You don't get it right the first go around, and it's hard to change.
I'm curious what's going to happen when you start trying to write code, like send a network packet.
Yeah, I think at that level, I'm going to claim I'm going to pass you along the OS error codes, and those are just thin wrappers over the OS. There's a version that says I want to do something exciting at the user level, like read a file or read a socket uniformly or whatever, for which, yeah, now the question becomes, is there a way to do an abstraction around reading from a URL or URI versus whatever? But send a socket.
Hopefully that's all standard library and not language.
Yeah. And then there's wrappers that say, on Windows, it looks like this, and on Linux, it looks like that. And can I wrap some abstraction layer slightly higher that runs them both and does close enough to the same thing and walk away with it? You know, hey, here I'm following a soft or hard link on Linux, and here I'm following the same kind of link on Windows. I'm iterating over the directory structures, and somebody believes in hard links and somebody does not, or whatever. Fuck it. I know there's link variations between Windows and Linux. I know there's socket variations and what it means to allocate memory and stuff. There's variations in these things. And that's where I think where I'm supposed to be able to do exciting stuff. We'll find out if it works. Fine. All right. I'm breaking for lunch.
Thank you.
Okay.
Good talking, folks. Until we meet again.